Hello friends, welcome back. We have seen different trigonometric functions. In this class, we are going to get still more information. Let us continue. Here I am going to talk about angles. Okay, little bit about angles. Now let's come back. Let us understand step by step. We know that this is 0 degree. And here we have 90 degree, and here we have 180 degree, here we have 270 degree, and when we come back we will be having 360 degree. This is the anti-clockwise. In anti-clockwise we have the degrees like this. Now angles will be positive as well as negative. Positive as well as negative. Negative, in the clockwise you are going to get negative. You can say like this is 0 degree and this one is minus 90 degree. Here you get minus 180 degree. Here you get minus 270 degree. And here you come back with minus 360 degree. You can represent one angle in many ways, you can say. Now let us take an example. Angles from here to here it is 90 degree. From here to here 180 degree, right? From here to here 180 degree. From here to here 270 degree. From here to here we are going to have 360 degree, right? One complete circle. Now let us take what will be from here to here. This is actually 360 plus 90. So 360 plus 90 degree, which is equal to 450. 450 degree. Let me show that 360 plus 90 is equal to 450 degree. What is 450 degree is indicating? 450 degree is actually 90 degree. Angles will continue. You can stay 0, 180, 270, 360, 450, and you can further continue 451, 452, 453, like that. Angles will be continuous. They will be continuous. Even same in the negative direction also. 0, minus 90, minus 180, minus 270, minus 360, minus 450 is actually equal to minus 90. I hope you guys are understanding. So angles will be positive or negative, anti-clockwise positive and clockwise negative, and angles will be continuous. They will be continuous. Only thing you need to remember that is like 360 plus 90 is 450. If you get 450 degree, you should understand that it is a 90 degree. If you get minus 450 degree, you should understand that it is minus 90 degree. I hope you guys are understanding what I am explaining over here. Why I am explaining this? Because of Atan2 function. Atan2. Atan2 function takes y and x, returns back us angle, right? It returns us angle in radians. And Atan2 function will return the values in this way. Let us take your object is 0 at 0 degree, it will return us 0. If it is over here, it will return 90 degree. If it is over here, it will return 180 degree. What the Atan2 gives, if your object is in this side, it will return you value between 0 to 180 degree. 180 is pi. If your object is in this side, if your object, if the game object or element or enemy is in this side of the coordinate system, then it will return the value between 0 to minus 180. So Atan2 function returns minus pi to pi. Between these values it will return based on the object, which side the object is present in the x-axis. Now let us take let me show the example so that you get an idea. For let us take the object is in this place. Object is in this place. And what will be the x value? X value will be 0 and y value will be -1. Okay. Now what it returns is, it won't return 270. It will return -90 because it is on this side. Now let me show that one. Let us check it out. Here what I do is we have a float and it is angle. An angle, not angle, we don't need angle anyhow. We can directly say debug.log. We can get the angle, no problem. Let's create one float variable called as angle. And we are going to get Mathf.Atan2 and we pass the y value first. Y value will be -1.0f and x value is 0.0f. So the object is present in this place. We have given 0 and -1 to this place. Now what it should return? It is going to return -90. I just show you. Debug.log, display the angle, and angle we are going to get in radians, so I am going to convert it into radians to degrees so that we get the angle in degree. Let us save and check out. If it is returning -90, we are correct. And if I run the code, you see that you got -90, guys. You didn't get 270. We should get actually 270, right? But we are getting -90. So remember that Atan2 function returns value between -pi to pi. That means -180 to 180. You people need to write a code. Let us take, you want to get the value from 0 to 360. You want to get complete all the values. Then you can use different technique. Let us take, I want to get 270 instead of -90. How do I get 270? What we need to do is, we can take the angle that we are getting over here, right, which is -90. If I add it, 360 degree. Now what happens? Okay, let us save. 360 minus 90. 360 minus 90, if you calculate, you are going to get 360 minus 90, you are going to get 270. You can see that. So you need to understand how do we write a code to get the required result. If I run the code, you should see now 270. So you need to add, actually we can say that 360 degree is 2 pi radians, right? So we can say here 2 into mathf.pi, right? That is 2 pi, and we have to multiply this by mathf.radians to degrees, because I should get here 360, right? So this is our 360. From here to here we are going to get 360. Okay, this is our 360, right? And we are adding that to the 90, right? If I save this and run, we should get the same output. And you can see soon, you can see that we got 270. Let us take an example that if the object is in this place, okay, if the object is in this place, according to our formula, what we get? Okay, if object is in that place, what will be the x? X will be 0, y will be 1. So we are going to pass here 1 and x will be 0. Let us save and run. Let us check it out what output we get. Okay, if I run the code, you see that you got 450 degree. Now what is 450 degree? 450 degree is actually 90 degree. 450 degree is equal to 90 degree. So whenever you are working with, if you want to get the angle from in the positive angle, you do not want to get the negative angle, then you can add 360 to it. 2 pi, then you will get the positive angles, and which you can use for any other calculations. Now let us take, this is our Cartesian system, and here we have 1, 2 and 3 and 4, and here we have 1 and 2 and 3 and 4. Let us take. Okay, if an object is present at here. The object is present in this place. So what will be the x value and y value? We can very easily get the. Now let us take, I just draw from here to here a line. Then I draw a line from here to here. Okay, that is our object's position. We are going to discuss little bit more over here, some information. So this will be 0, 0, and here the x value will be 3 and y value will be 4. Now we know from the origin, we know what is the value of x and y. This is x, so here x is equal to 3, we can see that, and this is y, and y is equal to 4. Now let us take, somebody asked you to find out what is this distance, what is the actual distance, okay, this distance, how do you find out? And somebody asked you that what is the angle, at what angle this object is present, how do you identify that one, how do you write a code for that one? Now this one, usually we say h or a hypotenuse, and this distance or the length we usually represent as the absolute value of h. And if you remember, we have a Pythagoras theorem. If you have a triangle which is of right angle triangle, then you can find out h is equal to square root of x square plus y square. This is a formula to get the h, this actual distance or the length from the origin to this object. Very useful information. Now what is x? You can calculate by yourself here. X is 3, 3 square is 9, plus y is 4, 4 square is 16 you get. So you are going to get square root of 9 plus 16 is 25, then h should be 5. You should get 5 on the screen, right? That is actual distance. Okay, you can find out using this formula, you can find out x, y and h. You can represent this in the code and we can get the angle also. What will be the angle? That is easy to, we know already how to find out the angle. We just need to give the y distance and the x distance. There are many ways to do that. Let us move further and write a code for that. Let us begin with first what we do. We just say first we find out the h. So how do we find out the h? For that I write one function which is going to return me a float, and the function name is get length, length. I can write in many ways. I can directly pass x and y. Here I can pass just x and y, but I want to get the x distance. I want to get this x distance. I want to find out myself. How do you find out? Let us consider this is one point, this is another point. What is this point? 0, 0. This is another point, 3, 4. So you can consider this one as x1, y1, and this point you can consider as x2, y2. So let us write the code for this one. Our function is going to take these points x1, y1, x2, y2 point. You can say here it takes a float x1 and it takes another float y1 and it takes another float x2, it takes another float y2. We have to pass these values to this function. So x1, y1, x2, y2 we get. Now we are going to find out the actual distance. So how do you find out the actual distance? Float x, that is our actual distance in x. The x distance we say. What is the x distance of this point? How much away in x-axis this point is? That is 3, right? We know that, but let us we calculate ourselves here. How do we calculate means? We say x2 minus x1. If I say x2 minus x1, we get the x distance. Correct or not, guys? x2 is 3. 3 minus 0, we get 3. That is x distance. Similarly, float y distance, we are going to say y2 minus y1. We get y distance. And you can see here y2 is 4. 4 minus y1. y1 is 0. 4 minus 0 is 4. That is the y value. Okay, we got x and y. You can say x distance or y distance. Then we need to find out the actual distance, right? We have now x distance and y distance. We will be using this formula. So let us write the formula here. Let us take a float h, that is our actual distance. So actual distance is equal to mathf dot square root of x square and y square. So we can write here x into x plus y into y. We can write like this, right? X square plus y square mathf of square root. Okay, simple. Then we are going to return that h, or we can say here mathf dot absolute of h. That's much better, right? So that is our length. We are going to get length in this way. Now whatever the value we get, let us check it out now. Let us get the length first. Get length function is going to give us the length. Now let us call the function, let us take one float variable which is going to give us a length, or you can say distance, whatever you say. Get length is a function which is our function, and we are going to, it is asking for x1, y1, x2, y2. x1 is 0.0f, 0.0f, and y1 is 0.0f, x2 is 3.0f, and y2 is 4.0f. So this is going to give us the length, and we can say debug.log display the length on the screen. I hope you guys are understanding the code, how it is useful and how do we write a code. This is our Pythagoras theorem, square root of x square plus y square. Let us save this, come back and run and check. We got 5. Interesting, right? Now let us check it out. I put a breakpoint and I explain so that you guys will be much more clear. And come back to Unity. If I run the code, now we are going to call the getLength function. x1 you can see 0, y1 is 0, x2 is 3, y2 is 4. Now x2 is 3, x1 is 0, so 3 minus 0 is 3, we are going to get in x. Now y2 is 4, 4 minus 0 is 4, we are going to get y4. Then we are going to calculate the square root function, and you can see that h is now 5, and absolute of that one we are going to return back, and you see that length is 5, and you can display that value on the screen. This is how you are going to write your own code to do some mathematical operations which are very useful. Now let us find out the angle. How do we find out the angle? So we can say here float get angle function, and we can pass here same, we can say we can pass all these 4 values. There is no problem in that, because which will be more better for us to use. And we find out the x distance and y distance. Of course we need that. Here I paste it, x distance and y distance we get. And we are going to say here float angle is equal to mathf.Atan2, and we pass y comma x. Then we return the angle, and let us check it out. Here float angle is equal to get angle. So we pass x1, y1, 0, 0, 0.0f, 0.0f, 3.0f, 4.0f, and we say debug.log is going to display us the angle, and let us take, I want to display the angle in degrees. So here while returning I am going to say multiply by mathf.radians to degrees, and I get here convert that angle to degrees and get back. Let us save and run and check. Let's clear this and let's run the code, and you can see that we got almost 53.1301 degrees. The object is at present from the origin. This is at 53.0 something. Okay guys, Now the code that we have written, this is not only used for checking the angle or distance in respect to the origin. You can use to find out, maybe let us take, you want to find out, let us take one point is over here, another point is over here, and you want to find out the actual distance between them, and you also want to find out the angle between them. Then you can pass this x1, y1, this x2, y2 to these functions and get the length and angle between them. I hope you guys are understanding how really the Pythagoras theorem is useful and how Atan2 function is useful to do many operations. We will be getting a lot of idea step by step. We get hands-on experience with the mathematical functions and the codes which are useful in games. And not only in games, you can say the programming that we are learning here is not only meant for gaming. It is meant for simulations you can do any other applications, mathematical applications. So there are many places where you can use the programming skills that we are learning here. Now we know everything. Let us proceed and just check it out what it is doing, so that once we run and trace it, okay, let us just trace and understand how the code is working. Okay, so here first getLength function is going to get call, we know that, and here we find out the x distance. 3 minus 0 we get 3, 4 minus 0 we get 4, right? We found out the distance. Then we are going to find out the square root of x square plus y square. We get the actual distance, that is the hypotenuse we say, or the length we say, or the distance we say. Then we get that back, and length we have got 5, and we display that one on the screen. Then we are going to call the getAngle. When I call the getAngle function, it is going to pass here x, y, okay, the values. x1 will be 0, y1 will be 0, x2 will be 3, y2 will be 4. First we are going to find the x distance, so we get 3. Next we find out the y distance, we get 4, right? X is 3 and y is 4, right? Here we pass 4, 3. We get the angle in radians. The angle that we have got is 0.92 something. We convert it to degrees. When we convert this to degrees, we are going to get the result for 53 point something. That we come back, and you can see that we have got the result, and then we are going to display that on the screen. This is how you can convert mathematical expressions or some functions to code. Okay guys, so we got some idea. So here you can see we have passed the values x1, y1, x2, y2. Instead of that, we can pass as these two as a one value, as a point 1. We can pass this value as a point 2, or maybe vector 1, vector 2, like that. We will see in the further classes, step by step. We get idea about how do we make it more optimized and more proper. I think for this class, this much is enough, guys. And remember this code, whatever I have explained. In future, they are really useful. What you people need to do is, you people need to create such functions. You just need to create such functions and keep in the library. Why? Because these functions you need not to write again and again. When you come across to find the length of length or an angle in your games, what you need to do is, in that time you just need to call these functions, use in many games, so they are reusable, right? Create reusable functions, and once you create, you can use them in many games. Find out different mathematical expressions, write your own functions, write the codes, and analyze and understand how do you write code, and those are really useful later. And build your own library of mathematical expressions or operations which are helpful in games. So for this class, this much is enough, guys. Keep learning, keep coding. Thank you guys. Thank you very much. See you in the next tutorial.